Okay. So first, when we are proving these, really what we're doing is I'm showing that this simplifies into this. You have to start with one side and work your way to the other. So I'm going to start with this, and when I multiply it out, I get this because I know that a squared minus b squared equals a minus b, a plus b. So when I do, I get 1 squared minus sine squared, but 1 squared is just 1. And since I know that sine squared plus cosine squared equals 1, I can subtract sine squared from both sides, and I get that cosine squared is just 1 minus sine squared. So I make that replacement, but if cosine is 1 over secant, cosine squared is 1 over secant squared, and I'm done. Here, instead of turning everything into sine and cosine first, it turns out in this problem, it's easier to first just FOIL it out. So this times this gives me this, and this times this gives me that. We're just doing the distributive law twice. This times this, I get that, and this times this, I get my last term. Well, then turning everything into sine and cosine, I get this, but then stuff simplifies. That just becomes 1. This just becomes negative 1. This becomes 1 over cosine, and this becomes negative cosine. So I'm only left with this, but I switch the order because I like the positive up front, and I get this, but then 1 over cosine is just secant. Well, then on 79, we want to find the trig functions for this mysterious angle. Well, they say it opens up into this quadrant, the third quadrant, and I know that to talk about an angle in a quadrant, I need to first open it, find a point on that terminal side, and then run to the x-axis to create my triangle. Now, in this case, to understand what this line is, they say first that your terminal side ends up being parallel to this. Well, that just means the same slope. So I solve for y equals mx plus b and get the slope is equal to 7 over 2. So that's my slope, but I also know that one point on this line is clearly 0, 0. So if I use y minus y1 is equal to mx minus x1, I can plug in for my slope of 7 over 2, and plug in 0, 0, and it ends up that my line, my blue line right here, is just y is equal to 7 over 2x. So then I can pick any point I want to on this line. Well, if I plug in negative 2, I find out that a point on this line is negative 7, because negative 2 plugged into my function gives me negative 7. So now that I know negative 7 is y and x is negative 2, I can end up solving for r using the Pythagorean theorem. I get plus or minus when I take the square root, but I know that r is always positive. So if that is my x, y, and r, then these are my 6 trig functions. Then, if I know that tangent is negative 3 over 4, and sine of theta is positive for number 85, so for this new question, well then, I know that this is y over x. So now I just have to figure out where does the negative go. Well, over here they tell me that sine is positive, but I know that sine is y. So it's telling me my y is positive. So the one on top must have been 3. The one on bottom is negative 4. So if that's my x and y, I use the Pythagorean theorem. I get r is equal to 5. And then I solve for my 6 trig functions. Or you can just know your 3, 4, 5 Pythagorean triple. 89, similar sort of problem. Negative 1 over 3 is my x over r. If sine is negative, then that means that y is negative. So when I plug this, negative 1 and 3, into the Pythagorean theorem, again, remember r is always positive, so I know that goes there. Doesn't really make a difference, but just being careful. So y is plus or minus square root of 8. How do I know it's negative? Well, because they told us it was. Plug everything into your 6 trig functions, and you're done. See you next time.